before I get into our new notes, I want to chat a little bit about the stuff that we talked about yesterday, about factoring. How many different methods of factoring did we end up talking about? 7. What are they? Full AC, GCF, the shortcut to the AC method, grouping, difference of squares, quadratic-like ones, and the sum or the difference of cubes. These. That being said, a little bit overwhelming when you've got all these different methods, but let's chat a little bit more closely about them. Okay, GCF and AC, those are ones that we should have talked about quite a bit. Shortcut. It's the shortcut to what? To the AC method, which means can't we just do regular AC method on it? So if you want fewer methods, you can ignore that one. Grouping. Now grouping was kind of new, but it was kind of not new at the same time. Why was it kind of not new? Because it's in the AC method. So if you have mastered AC method, should you have mastered grouping? Difference of squares. Here's the thing, I showed you difference of squares problems last chapter and we had never talked about this before. Because what other form of factoring can you do to do difference of squares? AC method. Quadratic-like equations. When they're quadratic-like, we address the fact that they're quadratic-like. We kind of mess with the exponents a little bit, but how do we end up factoring? The AC method. In all actuality, how many methods of factoring are there? 3. That's a shortcut. That's a feature of AC method. Technically, it's separate. You could do AC method on this. It's a shortcut. Quadratic-like ones still use AC method. In all actuality, I am asking you to master 3 forms of factoring. Greatest common factor, AC method, and then we've got the formula for the sum and the difference of cubes. So, I just wanted to address that a little bit, because I know some of you are looking at this and you're like overwhelmed on the number of different types of factoring, but for the most part, it's just about recognizing when you could do the different ones. You do greatest common factor always. You do AC method when it's quadratic or quadratic-like. In other words, it's an exponent of 2, or the exponents are bigger, but in an ax squared plus bx plus c kind of arrangement. And sum and difference of cubes you do when it's to the power of 3. The only other one that's a little bit oddball is grouping, but when it's got 4 pieces, that's when you're doing grouping, which is that halfway point of the AC method. Now, today, though, we're actually going to be making a bit of a turn away from purely factoring. It still focuses on the idea of talking about polynomials and their factored form. But today, the questions are going to be a little bit different. Today, it answers a separate question. Sometimes when it comes to working with polynomials, we don't actually need a fully factored form. Sometimes we just need to know if something is a factor of it. Now you can factor it completely if it's something you know how to factor, or we can do something else. So today you're going to see questions like, determine if the binomial is a factor of the polynomial. specifically the polynomial f of x, because a binomial in itself is a polynomial. I'm going to give you f of x is equal to 2x squared plus 5x minus 12 . And the binomial is x minus 4. What does it mean for something to be a factor of a larger polynomial? For example, x squared plus 2x minus 3 has factors of x plus 3 and x minus 1. What does it mean for x minus 1 to be a factor of this? What has to be true about it? It divides by it. It divides by it evenly. How do you know if things divide evenly? Like, how do you know that 8, I don't know why I wrote 3, 836, how do you know if that divides by 9 nicely or not? You go to a calculator and you look at what? How do I know that doesn't divide nicely? The decimals. What are the decimals a result of when you're doing the division? If you were just straight up doing long division, what's you're going to see with the decimals? The remainder. There's a remainder that is not what? It divides evenly means the remainder is what number? 0. If you want to determine if a binomial is a factor of a polynomial, start dividing and see if the remainder is 0. If I'm dividing a polynomial by a binomial, there's 2 different forms of dividing that could take place. What are they? Synthetic division or long division. Synthetic doesn't always work. Can I synthetic divide here? Yes, because what I'm dividing by is a binomial with exponent of 1 and leading coefficient of 1. So I can do synthetic division here. Oh, yeah, 4.3 was divided.
Yeah, but on the back side at the bottom.
No, it was similar. It was related to it. It's going to be something that we're moving towards. Okay, what goes in the little box? Regular 4. What goes across here? 2, 5, negative 12. Making sure that you don't have any missing terms. It went from squared to regular x to constant. Is that okay? Yes. How do I synthetically divide? Bring the 2 down, it's a 2, and then I multiply. 4 times 2 is 8, I write it there, and then we add, and then we multiply. 4 times 13 is 52, and then we add. What's the remainder? It's always this one, so that's the remainder. If the remainder is 40, is it a binomial, or is it a factor then? No. And a little note to self. It is a factor if it's 0, because we didn't actually write that down. x cubed minus 5x squared minus 9x plus 45, and I'm checking if it divides by x minus 5. Can I synthetic divide? Yes. If you don't like synthetic division, can you do long division? Yeah. I'm going to synthetic, but you like long division? Go for it. What goes in the little box again? 5. What goes across the top? Do it. Divide it. Multiply the next. What's the remainder? 0. Is it a factor? Yes, it is a factor. In fact, when I long divided, in all technicality, I just got one x to what power?
2.
X squared, no regular x's, and minus 9. X cubed minus 5x squared minus 9x plus 45 could have been written as x squared minus 9 times x minus 5. That is a factored form of it. Is it a fully factored form? Or can it factor further? It can factor further. What are you noticing with x squared minus 9? What kind of factoring can we do? Yes, AC, but what's the shortcut that works for it? Nope. Okay, technically, yes, you could do the AC shortcut. There's a shorter version. Difference of squares. It's a perfect square minus a perfect square. This is a factored form, but it's not completely factored. Yes. Well, actually on this problem it just asks if it's a factor. But on questions like the next one, yes, you would end up losing points. Because the other set of instructions you're going to see today are going to say, show that the binomial is a factor, and factor completely. slight change in instructions, but much of the process is going to be the same. The difference is, on these questions, I just asked, was it a factor or was it not? So the yes or the no really was the answer on these ones. Now I took this one a step further and did this, which is where we're going with these. I know it's a factor. How do I show it's a factor? My options are factor completely to do that, or divide it out and show that the remainder is 0. Can I do synthetic division? Yes. In the little box is going to go positive 6. Across the top is going to go 1, negative 5, negative 6, 0. It's missing a constant term. So I need to make sure it's on there before I do long division or synthetic division. Pull down the first term, I get 1. I multiply, I add, I multiply, I add, I multiply, I add. 6 times 1 is 6. I add, I get 1. 6 times 1 is 6. I add, I get 0. 6 times 0 is 0. I add, I get 0. Remainder equals 0 means it is a factor. But now it says to factor it completely. I know that one of its factors is x minus 6. What do I currently have for another factor of it? In other words, what is this telling me? 1x to what power? Squared plus 1x plus 0 constants, and there shouldn't be a fraction. So far I have this, but can I factor it further? X squared plus x is what you're looking at, because that's got the exponent. The piece that doesn't have an exponent will not factor further, unless you missed a GCF. This. To factor a quadratic binomial, I've got two options. It's either a difference of squares or it's got a greatest common factor. It's got a greatest common factor of x. Put that way out front. We don't want to put it in the middle. This x minus 6 I didn't touch. And if I factor the x out of this, what am I left with? X plus 1. That's fully factored. All of those are linear terms. All of those have an exponent of 1. Now, one of the things you have to know is if I tell you it's a factor and you do not get a remainder of 0, what's that telling you? Something's wrong. Either I screwed up the problem, which happens at times, don't get me wrong, or you screwed up the division. Realistically, I've been doing long division of polynomials longer than you've been alive, so who's most likely to have made the mistake? You. So, double check your work at that point. Okay, so I'm going to divide these. Can I do synthetic? No, my binomial has a coefficient on it, so I'm doing long division. 2x plus 1 goes here. Am I missing any terms? No, it goes 3, 2, 1, constant. We're good. What do I multiply by 2x to get 2x to the third power? X to the second power. So remember, you got to multiply the exponents, or sorry, add the exponents when you're multiplying. Oh my goodness, I'm saying it backwards. Add the exponents when multiplying. So what do you multiply by 1? What do you add to 1 to get 3? Sorry. Anyway, you got x squared. Okay, off to the side. Remember to do your x squared times what? 2x plus 1. 2x to the third power plus x squared. And then we subtract. Easiest way to subtract? Distribute the negative and add. That cancels out. Negative 7x squared plus a negative x squared. Negative 8x squared. And pull down the next term. That is one thing that I saw people making mistakes on the last quiz. Don't forget to pull down the next term. And repeat the process. What do I multiply by 2x to get negative 8x squared? Negative 4x. Negative 4x gets multiplied by 2x plus 1. I get negative 8x squared and negative 4x. I subtract by distributing the negative. That becomes positive, and now I'm adding. Cancel. Negative 46x plus 4x. Negative 42x. Bring down your next term. What do you multiply by 2x to get negative 42x? Negative 21. Negative 21 multiplying by 2x plus 1. I get negative 42x, and I don't know why I wrote positive, negative 21. But then when I distribute the negative, it becomes positive. And they cancel out. My remainder is 0. Did I do it right? Yep. What do we know so far? The remainder is 0. It divided out nicely. What do we know about the factored form so far? X squared minus 4x minus 21 and 2x plus 1. That's what I know so far. Can I factor further? Maybe. I gotta at least check. I got it squared here. Now I noticed it's a trinomial, which makes me think AC method. Can I do the shortcut? Two things that multiply to negative 21 but add to negative 4? 3 and negative 7. What if no two numbers existed? Then that would be the fully factored form. X plus 3, x minus 7. Because I'm doing the shortcut, I can go directly to the parentheses. If I was doing the full AC method, I could not. And don't forget the 2x plus 1 that we also had already factored out. That's what you're seeing today. Yeah, we're back to the book. We're on page 180. It's numbers 35 through 46. We do have a quiz today as well. I'll give that to you at the end of class. It is 4 problems that say factor completely.